Hello everyone, my name is Ming. Um, this is my first time to upload a video. So the reason I'm doing this is because recently I feels like I'm a little bit slow on processing data using, especially using the Pandas method. So I want to get some more solid skill on Pandas library, which is the one of the most important Python library that everyone uses in the data science field. Not only data science field, I mean every other jobs or tasks that are related to manipulate data. Pandas comes to very handy. And after some search, I think there's one of a very good source of practicing is called the Pandas exercise. Okay, so let's see. Excuse my. Okay, yes. So on GitHub, so there's one repo. It's called a Panda exercise. If you Google, you'll find it. The owner of the repo is Gibsamora. So thank him very much for getting this exercise. So just need to git clone to your local repository, and it has for each session it has exercise solutions. So for solutions, it only has like the answers without the code. So you can use this to compare your result and also solution exercise with solutions. Cool. So I would definitely recommend to start from exercises. Um, so and then checking with the result. If you cannot figure out, you can check out the exercise and redo it. Do it several times just to make sure you know how to do it in the future. So this is my first time to do this as well. So let's do it together. There definitely will be multiple ways to do it. So um, I'm just gonna do it first based on my own understanding and the methodology, and then if I check for the exercise, there definitely may be better solutions for that. So please let me know if you find some more elegant way of doing this or more Pythonic way of doing this. So I already cloned it in my desktop folder, so I just directly. Oh, I'm already here. Okay, so I just start Jupyter Notebook. All right, there it is. I usually have it side by side. So I have one window for Google for the syntax and then another window for the thing I'm doing. So before I recorded this video, I already did the first. I already finished the first two. So I'm gonna start with the third one, and then later on I'll redo the first two. So I will make up the video for that. I think I'm here in the regiment. Yes. Okay, I'm here. So yeah, credits goes to Chris Aborn for sharing the datasets. Yeah, I use his flashcards for review some knowledges. Really good. Check it out if you want. Cool. All right, let's go to exercises. Import step one. Import the necessary libraries. So let's import pandas as PD. Okay. So create a data frame with the following values. All right. Assign it to a variable called regiment. Don't forget to name each column. Okay, so let's check it out. Regiment is equal to PD data frame. So you can create a data frame directly from dictionary. And we can do regiment head to check the first few. Oh, sorry, I forgot running as well. Okay. And each column. Okay, it has column name here because it's defined in the dictionary. I'm good. What's the mean pretest score for the regiment Nighthawks? Okay, Nighthawks. What we can do is select the regiment where Nighthawks. Oh, sorry. Regiment. This column equal to value net out. And then we just submit. Yeah, this gives my pre-test score and the post-test score. I just need the pre-test score. So probably I can do just one. Yep. Yes, just keep the header there. Okay. So present general statistics by company. Okay. So by company for a second. I think what we can do is using group by method by school company and then describe. Let's see if it works. Yes. Okay. So it now has two companies and then shows all the statistics of it. Pre-score, okay, test score. It shows count mean, standard deviation mean, quantile. Or alternatively, I mean, if you just want, for example, count mean stands, what we can do is arrangement group by company, then aggregate function. So for each one, we want count in CD in max. Maybe we can do sum. Does it make sense? Yeah, that's so. Yep, the return is. So those are the functions that are available there. Or if you want some customized function, you can do lambda. For example, do a lambda. For example, lambda x. So for each one, we have the let's see. Let's do the first one. Let's return the first value. Yeah, that has it here. 4. Okay. So this is just a demonstrate other ways of the customized aggregation function. So what does it mean of each company? What does it mean of each company's pre-test score? Okay, so this one what we can do is arrangement. Just to look at the company, and we need a array. Company and pre-test score. Okay, and then group by company, and then we need the mean. Okay, let's go to this. Present the mean pre-test score group by arrangement and company. Okay, so arrangement just 4. Initially, I only use the necessary information. Pre-test score. So, and then I can group by, not necessarily take an array, just my personal preference, and then just a name. Actually, this gives me an answer because I do need a reference one because also group by arrangement. All right, here it is. Ooh. Yep. Present the mean pre-test score group by arrangement and the company without hierarchical index. Okay, without hierarchical index. Okay, so let me try one method. We copy this one. Reset index. Yeah, here it is. And let me do, because this is good enough. Group the entire framework by arrangement and a company. Okay, so we just arrangement group by arrangement company. Oh, group internal by. Yeah, I think this is what it asked for. Didn't provide any. Question didn't ask any aggregation. What's the number of observations for each region? Okay, so here it is. Count. Yep. What's the number of observations of each region? Okay, so here give me redundant information, right? So I probably just his name. Yeah, I guess this is okay. What I mean is I just use the count for without display 3. But this should be good enough for the next answer. Iterate over a group and print the name and the whole data of the what then this requires iterate over a group and print the name and the whole data from the region. Okay, so I guess it's for group in regiment group by regiment, because this one is just one category for group Y, just use regiment. So I can print group. So, yep. So yes, scout regiment company name. Dragon. So let me see what's the regiment. Oh, okay. Group by 0. Oh, okay. So what I can do, group 1. Cool. Yeah, that's what it is. Alright, so let's look at the exercise with the solutions. Alright. That's fine. Without comments, okay. Okay, so let's see. Data step 1, data column, data keys. Well, I guess it's not necessary because I already have this. Let me double check. Regiment columns. Okay. I have everything, so that should be okay. So I think it's not. This is unnecessary. Regiment mean. Management. Well, what's the mean preschool for the regiment? Yeah, see? It has. No, I don't think this is a correct answer. It only asks for the Nighthawks. Okay, I think mine is better. Regiment group by company describe. Okay. Oh, I don't know if you guys noticed this. So let me try. The difference of adding parentheses, square parentheses, and square bracket or not. Oh, okay. Okay, I thought. Notice how the result returns it's by column, but here is my it's by row, but my solution is by column. I guess this is different Panda version, so that's probably okay. Oh, what I did. Okay. So what is the mean of the company's which company pretest score? Company pretest score is pretest score mean. Cool. I think that's okay. Just returns slightly different because it group by company and then pick up the pretest score and then calculate mean. At first, I only pick up the necessary information and then group by. Originally, group by pretest score. Yeah, I mean, basically it's the same information. Oh, it called unstock without hierarchical indexing. I just reset is okay. It's called unstock. Okay, so let me try its method because the question doesn't ask specifically its form. So let me try it. and stack. Ah, okay. So this first time knowing this and stack. So let me check pandas and stack. Pandas and stack. Check for the document. Come on. By default, it's the last level. Make one last level. Double this to stack compass level names. Pivot a level. Okay, pivot returns a different having a new level called labels whose innermost level is consistent with the pivoted index level. Cool. If the index is not multi-index, the output will be a series. Okay. If not, it will be a pivot table like this, cross tab. Okay. This is something new. So let me try. How about level 0? Then it goes to this way. Okay. Something new. The comment. Something new. So number 9. Group the entire data frame. Group the entire data frame. Okay, it didn't ask, but yeah, I can do main, I can do count, I can do sum. So 10. Oh, this definitely, I think this might be a better method. Okay, so let me write it down. Size. Yeah, this is a better method. Let's try stack. Okay. Yeah, redundant information I don't need. Okay. Size. How about reset index? Anything. Yeah, this probably good. Cool. Step 11. Oh, to use the okay unpacked version. So this is just a two group. So I also can do. So this is a tag and the content. Basically, what it is content. Or let me do label. Which is one of this basic value that belong to regiment, and the content is given this label, given this value of the regiment, what's the corresponding, the rest of the information that correspond to this, corresponding to dragoons, and Nighthawks, Scots. Yeah, they have 3 groups. So one good visual, I think we can find a pandas group by search. Alright, let's open the images. Yeah, I think this one. This is this is a very great demonstration of how group by works. See, it does actually, after you apply group by, it split it to 3 chunks based on this account value, and then apply the sum function, which apply aggregate function, which is a sum, and reduce this, and then combine them together. Okay. Yeah, this one will be better. Yes, this one. Split, aggregate by sum, and then combine. Yeah. This is literally this what it does. What different is here is only split by 1 by order, right? So here we split by regiment and content. That's it. Cool. I think we'll definitely learn some new stuff. The stack here from this one, or from this exercise. Sorry for my English. So let me go to the next one. Apply. Okay, it's ready? All right, let's start. Student alcohol consumption. Exercise. Each time I need to specify. Okay, something's wrong with the conda. I need to clean it up, but I'll do it later. Student alcohol consumption introduction. This time you will download the asset from UCI. All right, okay, sounds good. Import Pandas as PD. Okay, so here's this. Let's check it out. Okay, looks like CSV. So we do EF equal to PD read CSV. Oh yeah, it is CSV. So I just read it. All right. Let me check. EF head. School, sex, age, address, fam size, P status, MEDU, FEDU, I guess mother education, mother job, father job. Oh, 33 columns. Okay. Okay. For the purpose of this exercise, slice the data frame from school into garden column. Garden column. Okay, that's me to slides, but before that, I need to. It's by column, so I need to know what the. Okay, there's several ways. So let me first print out the columns. So BF columns. School all the way to garden. Okay, so 1, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from 1 to 12. So what we can first way 1 to 12. First way what we can do is allocate. So all the rows start from beginning. Let me write it specifically from 0 to 12. So 12 index 11, and it's not include the last one. So from 0 to 11. Cool. Yes, there it is. And another way we possibly can do is without actually checking what the columns are. It's EF transpose. All right. Okay. So okay. Now what we can do is actually locate. So here I can do school all the way to garden. All right, then I transpose it back. Right, same result. Two methods. Create a lambda function that will capitalize strings. Okay, so let's call cap string equal to lambda x. So what it does, capitalize strings. I need to search it. I don't know. Python capitalize string. What's the method? Upper, I guess. String name capitalize. Okay. X capitalize. Okay, let's test it. String hello. Okay, screen. Capitalize both mjo and fjo. So what we can do is select mjob and fjob, apply. So let's check the apply. So we give the function and then access by default is by row. That's fine. And broadcast. No, okay, we don't need this one. We just need a cap string. Oh, okay. What's wrong is that it's gonna feed into the. It's gonna feed a entire series into Panda. So what we cannot do this. So what we can do is I dot capitalized for I in X. Yep, here it is. Okay, cool. Print last element of the data sets. Last element of the data set. Last observation. So we can use the allocation, which is using index. df alloc. So last element every column. Did you notice the original data frame is still lowercases? Why is it? Yeah, because this apply is not in place. It returns a new data frame. Fix it and capitalize. Okay, so what we can do is just reassign. And just print it out. Now it is reassign. Cool. Create a function called majority that returns a Boolean value to a new column called legal drinker. Consider majority as older than 17 years old. To the function majority that returns a value to a new column. So I guess it takes the diff as argument to a new column called okay, so we can still use lambda function, I guess. Majority is equal to lambda x. So it will gonna return a new. Can you return a new column? Okay, so it's a Boolean variable, right? So we can do for I in x. So we can use I. Let's check Python's primitive type, data type. This should be good enough. Just want to make sure it's actually showed as true or false instead of 0 and 1. False, Boolean, type bool. Okay, so we can test the bool. Yeah. Okay, so this is what I need. This is needed to bool. Okay. That's older than, okay. So what we can do is diff legal drinker equal to diff. We need age. Let's see if age is here. Yes, age is here. Age. Apply. Font. Check it again. Font. Font equal to majority. Oh. Oh, wait. Oh, okay. So if we select a 2, it will feed in a column. However, we only select 1, it feed in integer. So our lambda function will be, x will be an integer. So we just need to return bool x larger than 17. Okay, so let's check this out. Yeah, true, false, true, false, true, false. Actually, let's print age here as well. 18 true, 17 false. Okay, looks good. Cool. Multiply every number of data sets. Every number of data sets by 10. Every number. Okay. So what we can do? Append every number of data sets. Don't forget it's just an access. Okay. What we can do is multiple ways. First, we can just select by type, and then times 10, or use apply function. Since this exercise, I'm going to use apply function. So ef apply. So we need a function here. So let's just directly use lambda. So lambda going to be column. So if x, do this, it will be a, so what we need is if x is 0 element, b type is the number. Number could be integer, could be float. So let's check what's available. B types. Object int. Okay, it's either integer or this. So what we can do? If d type equal to int, so bf h b type equal to int 64. Yes. Okay. So this will work. So if it's a int, we're gonna return I times 10. For I, actually we can just directly x times 10, else return x. Okay. Yeah, there we go. Cool. You can do this one. All right, let's check the exercise solution. Let me put it here. Continue with our kernel. All right, this one, read the data. Okay, SSB, no problem. DF location. Oh, interesting. Okay, so this is something I don't know before. I did it like transpose and then transpose it back. Actually, for column, we can do the same thing using this column operator. As long as it's consecutive, it's okay. Okay, that's good to know. Let me transpose. Ooh. Calculator. Capitalize. Okay. See, here's the difference. The solution just select the one by one. Then what fit into this this lambda function is just an individual element. So, however, here I'm selecting a data frame. So what goes into apply is the element of that data frame. Actually, that's a 2D. What underneath is a 2D numpy array. So it will the first second element of that 2D numpy array is array by itself. So that's why what goes to lambda function, given my setting right now, like this, is a array. So I have to do this one, the list of comprehension. Cool. Print the last element. Oh, okay, this is smarter. I forgot tail. Oh, no, tail, you can do one. Yes, I electric tail one. Yeah, this emerge, you can just apply this. Oh, okay. Lambda function is more Pythonic, I think. I prefer my answer. Okay. Similar method, I prefer my own. So just in line with Siemens to make it really, really easy to read. Okay. Cool. All right. Up to now, we finished another one. Yeah. Substitution. Okay. Let me finish this one and let's take a shorter exercise. Oh, sorry. Shorter break. Let's get my tea. So, kernel. Crime rates. Nice. Crime identification. This time you will create data. Cool. Special thanks to just Markham. Thank you, just Markham. In the datasets, import the necessary libraries. Let's import Pandas. Sometimes I do NumPy as well. Let's NumPy, NP, SPD. Cool. Import. Okay, so let's get this dataset. It looks like still facing this. Yeah, it's CSV. So called crime equal to PD read CSV. This time we're gonna do this one. Okay, cool. So crime type. All right, here's our data. Looks like all numeric. So let's just check one more. Point prime b types. Yes. Prime. Complete all integer. All right, sounds good. Looks good. What's the type of the columns? Okay, so let's do prime columns. Year population, total violent, property murder. I won't read it all. Have you noticed that the type of New York type of year is inter 46, but the pandas has different type to work with temperatures? Let's see it now. Okay, great. Convert the type of column year to date times 64. Okay, so let's do prime. I usually do this way of selecting. Let's do d type equal to date time 64. Prime year. Set attributes. Okay, so okay, nice. Well, type. That's type. Okay. Date time. Okay, so I need Google here. So convert year to date time 64 pandas. Date functionality time series. Nice. What's AS? What does AS mean? Oh, okay. We just use here. So here's abbreviation. It takes keys like abbreviation. So we just do this. And start copying this. 8 times 64 is not defined. Alright, let me try one more time. Data type is not understood. Okay, year 19. Prime year. So, convert column data type mass assumption. About 2-day time. What I'll do is let me try this one. PD2 date time. Okay, so I'm gonna pass cron here, and then I'll give it format. So format equal to, yeah, okay, so let me check it out. Okay, datetime 64. Yeah, this is datetime 64. Set year column as index of data frame. All right. So prime index then equal to prime. Yeah. Okay. Delete the total column. Okay. So I don't know what's the syntax of deleting. Okay, pandas delete column. Let's just make it equal to null. Drop access. Okay, so what we can do is prime drop. Oh, that's hard. Just kidding. Cool. So let's see. We need the in place equal yes. So in place means if this happen in place, I think indicates. So if we set in place to true, it will modify the crime object, crime data frame itself. If we set in place as false as its default, it will return new data frame, which leaves crime untouched or intact. Payment to the group the year by decades and sum the values. Pay attention to the population column number. Sum this column is a mistake. Okay, so population by decades. What can I do that by decades? Not in decades, 20 decades. So I just need, okay, extract decades from date time for pandas. Oh, okay. Oh, okay. So this seems to actually is this. So especially this answer, the same problem I have here. If your data frame has headers, say population, vehicle counts, vehicle shift. Oh, it's different. Okay, make your index as year data frame set index. Year. Oh, this is a better method, set index, because if we do this, we will do. If we do index this, let's print prime again. You can see that the year is still here. So let's see this. Let's see our year set index year. Now it has dropped in the original index. This is a method. This is a bit better method. There's something new. It's in place. Okay, so we need to make it in place as well. In place to the true. It won't return it because it's modified the original one. Okay, now this one. Okay, I need to redo it. Use below colon recycle data in decade of 10 years and also give you some of all the columns with decades. Understand what's 10 is 10 here. Set index date is something. Okay, let me search this Panda example. Convenient method for frequency conversion and resample of time series. Object must be time-like index. Okay, it's our case. Three minutes. That's about 30 seconds. Frequency W. Where is the? Oh, here. Okay. Which set of B interval closed? The frequency. And ABQW. Okay, so let's check the user guide. We need 10 decades. What this short letter means? D? Does D means day? In day? So D. A period represents a span of time. Day must called extra. You can specify your frequency. Okay. Here is daily or higher. Let's look into this. Okay. We can find the index. Okay, so let me search further. Date. Oh, this one. That is me. So it's 10 AIs. Okay, so looks like this one tells it is decades. All counts. All right. So let's check it out. With some, let's see which samples there. Oh. yeah, look to do the trick, but how to generalize this one? Period in Panda. What does this mean? What does the short abbreviation mean? D means daily, right? This means years. Okay, I don't know about this. So if you guys know, please let me know. Okay. Seems to the trick, but let me check the population. Yeah. Some it's common mistake. Okay, I'll check the result. I spent too much time on this. What's the most dangerous decade to live in the US? Okay, so this is like the insights question. So let's see, what's the most dangerous way? I would do some calculations. Violent, poverty. Oh, I know what it means. We need a resample AGG. Let's do this. Population, POPO population. We need and then we need spread it out some. Sampler. So let's see. Let's sample next. AGG. We'll try the name. So, okay, cool. Had this. So what we can do is reset index level equal to 0. Let's go ahead this. And stack. No. Okay, I'll just check that real fast. Here. So aggregate function we need speed. How can we see this? Pandas. Oh my god, it's so slow. Hopefully. AGG. Just getting slow. What I want to do is actually I only want to apply mean aggregation function on population, but for the rest of the column I apply sum. Remember, aggregate this one does the aggregate function does takes like separator. Obviously, see it counts for this, I think. AGG, okay. Oh, cool. Just need to do the rest. Okay. So crime columns, publish violent, some. Okay, let's make the copies. Well, it's a tedious, but this might not be the great way. But I think this is the best way I can think of right now. Let's get the job done and look at the solutions. Perfect. Reset index level to 0. Oh, I was wrong. It was bad because I make it in place now. Oh no, no matter, because it was another after some resample, another one. Okay, this is good. The rest was some. So what I can do then? Let me call this to crime resample. So what I can do is columns equal to crime columns. Now it's great. Why I'm doing this? Because to answer this question, just look at the number might not be correct. Okay. So I can do this reset index. Population mean multiple index. That's fine. What's the reset index level equal to 1? And then I make it two crime columns. Ooh. Example. Oh, no. Okay. So I forgot. So how to reset multi-index columns panda. Yep. Multi-index from array index. Okay, because probably we don't need the days. What we can do is prime sample columns equal to crime resample columns drop level here. Okay, cool. So let's check it out. Perfect. Oh, nice. Perfect. So that's what we need. So we want to see that what's the most dangerous decade to live with. To answer the question, what I want to do is basically sum all over this and then divide population to get the ratio. Okay. So in order to do that, we need a crime resample. Allocate all the rows from first one to last one. Sum access. I want to return by column equal to 1. Yeah, just give me this. And then I just divide by this one. I'll do element-wise derivation. So, okay. Just two values. A little bit sleepy right now, so I'm gonna do. Oh, so here I need to just select the population. Okay, so let's see. Definitely, they see a 1, 2, 3. 1, 2, 3. So answer for me is 80s. 80s is the most dangerous decade to live in the US. All right, let's check the answer finally. But I'm sure this one I can learn a lot from because I don't know a lot of them. Continue with our kernel. So first the fields, okay, give me this info, okay, cool. I probably can use info, but I use head D types. Oh, it used to data time. Oh yeah, same as one. Index drop, set index I'm using in place. It's not in place but assign. Okay, cool. Crime total. Delete crime total. What I did is just drop total. Right. Crime resample testing. To learn with sample. Okay. Oh, here's the resample. Okay. I need to read more about that. Oh, it uses max. Okay, I'm using min, so probably I can use max as well. Let me change max. Okay. Same answer. '90s. Why '90s? Yeah, you have the most of crime. However, you have more population as well, right? So I still go for mine. I think this relative ratio matters better. Cool. All right. Thank you everyone for your time. I think today we can call it off. Again, this is my first video, and I hope this can help you guys. Definitely, I learned a lot from this exercise, and um, hope we can grow together. Thank you very much.